we took a step-by-step look at the journey through working of blockchain. Today is day number 3, and we'll build upon that knowledge and explore the world of blockchain transactions and the blocks. So I hope you're ready to deepen your understanding to this revolutionary technology. Let's dive in. To fully grasp the inner working, we need to understand the structure in the blockchain, right? What's happening inside the blockchain. Transactions are like records that contain the information about the sender, about the recipient, and about the value being transferred, right? These transactions are crucial components of the blockchain. Now, let me show you uh, some more visuals, right? Give me a few seconds. I'll launch my screen, share my screen, and yes, I hope you're able to see this. Okay, so now diving deeper into this. So this shows an overview of the blockchain transaction, right? To ensure the security and integrity of the transactions, blockchain employ use of public and private keys. So we'll go into this again in the next couple of slides. Public key act as an address that users share to receive the transaction, while private key acts as a secret code to allow users to access the authorized transactions. Means public is to give the transaction, and the private key is to access, right? Access and authorize the transaction. These keys play a pivotal role in verifying authenticity of the transactions. So I'll just dive deep into what is public key and what is private key now. So as you can see here, this illustration shows what is a public key and what is a private key, right? So let's zoom and take a broader view. So when a transaction is initiated, it is broadcasted to the entire blockchain. Entire blockchain. All the nodes in the network receive this information of the transaction, along with numerous other transactions happening simultaneously. So these nodes often referred to as miners, who on confirming the recording of this transaction into block. And that's why, as I mentioned, so for transmitting the things, the sending the things, people use private keys, and for grabbing the things, they use private key. I said other way. For transmitting, it is a public key, and for gathering the information, it is private keys. I hope you got a little bit of this, right? So you can see in this that how the sender is sending, it is encrypted using public key, and when the other receiver is receiving, he uses his own private key to decrypt the data and then receive it, right? So same, it's a bit of more elaboration in the another diagram below, that it is showing, and it is having some more text, right? So it is giving details how the public key is used and how private key is used, and it is used for how it is added in the transactions, and finally this is a different representation of the same thing. So if you want, you can just pause and read this, because since we have a very short time, I don't want to read it further. So this is how the public and private key is used, right? So now I will go into the next illustration, that is broadcasting of a transaction. So let me go to that. So this is the number 3.3, broadcasting, how the broadcasting of transaction is done. So confirming and recording transaction involves a very meticulous process. And minus collects the multiple transactions that have been broadcasted and group them together into what is called as a block. So this block serves as a collection of transactions, similar to entries in a ledger, right? So ledger में क्या होता है, जो भी transaction है, so those gets entered, right? So similarly, so this block serves as a collection of transactions, any block, right? It is through this process that transactions become a permanent part of blockchain. So as you can see here, right? And furthermore, to ensure integrity of the data within the block, blockchain utilizes a structure called Merkle tree. So Merkle tree will take a look at it further, and now you can see this thing, how the nodes raise a request, transaction is represented, then the block is broadcasted to all the network, and then the transaction is validated by the nodes. And then once it is validated by multiple nodes, then the block is getting added and transaction is marked as a complete, right? So as I said, let us now deep dive into what is Merkle tree. So this is again a part of insurance of integrity. That's why we use the Merkle tree. So the Merkle tree plays a vital role in maintaining the security and consistency of data. It uses cryptographic hash functions to create unique hash for each of the transaction, when which is then used to construct the Merkle tree. So as you can see, the how the Merkle tree, as the transaction is confirmed and recorded in the block, these blocks are linked together to form a chain of the blocks, which is called as a blockchain. Each block in the chain is reference to the previous block, and this ensures immutability and transparency. So as you can see, any transactions like at the bottom, there are multiple transactions happening A, B, C, D, and for that we have these hash keys, and again that hash key is merged, and as I have mentioned, so then it goes into the Merkle root, and that is again the hash is linked to the previous hash, and then again it will link to the next hash. So that's how. So what happens is the transactions uh, hashes are created, and those hashes get merged, and then those are linked to previous block and the next block. So this is the complete what do you say, complete Merkle tree structure. It's a big complex. I think explaining it in a few seconds is very difficult, but just understand that all the transactions are collated together and hash keys are created, and those hash keys are merged for given block, and then those are uh, kind of connected to previous and next block. So that's how it is kind of linked and made secure, more secure, right? So now we will look into the next thing. So that is how the linking of the block happens. As I said in the previous slide, that linking is happen. It's worth noting that blockchain has a certain limitation, such as size of blocks. Each block has a predetermined size, which imposes a constraint on the number of transactions that can accommodate. At the same time, as the same number of transactions increase, the blockchain must address scalability while maintaining the security. So that's why we have this. What do you say? Multiple blocks are created. Each block in the chain includes a reference to the previous block, creating a continuous secure flow of information. This chain of the block ensures immutability and transparency. That's how it is mentioned here, right? We have seen that how the things hash of the previous block. So you can see here, right? Block 1, block 2, block 3, and each of the hash is pointing to the next block, right? So that's how these are linked together, and same thing is explained here. So the transactions are linked together with the previous hash, and that's how it is making more secure. So if anyone tries to tamper any block in between, everything gets notified, the previous block and next block and all the nodes. Then it raises alarm, and then that's why it doesn't allow any what do you say, any irrelevant things to happen, or irrelevant this thing transaction to happen, right? So we have seen how the we have now explored the blockchain transaction in the blocks. We have covered the structure of transactions, the role of public and private keys, the process of confirming the records and the transaction, the significance of Merkle tree and the data integrity, and consideration of the block size limitations, right? So we have learned something new, and I hope you found this session informative and engaging. Understanding blockchain transaction is essential for navigating the intricacies. Keep exploring, and you can maybe do you some more research and gain some more knowledge as the blockchain continue to reshape our world. Join me the next session. We'll be diving into the next exciting aspects of the blockchain. Until then, keep embracing the power of blockchain, right? Thank you so much, and I'll see you in the next session. Bye bye.